Hi everybody, this is lesson 3.4, Picturing Data. Let's read the specific objectives for this lesson. Students will understand that histogram and box plot are ways to visualize raw data. Histogram and box plot help one see the patterns and trends. Students will be able to construct histogram from ungrouped data, calculate 5-number summary, and construct box plot from it. So in this lesson, we're stepping away from probability and discussing some other topics taken from statistics. And today we're going to be picturing the data. So let's look at the problem situation number 1. Kate Johnson has been teaching a quantitative reasoning course for the past 2 years at a community college in upstate New York. Last semester, she taught 2 sections of the same course. One section used traditional textbook, while the other section used a new experimental curriculum. Kate administered the same uniform final examination at the end of spring 2017 semester, and Table 1 lists examination scores of her students. So take a look at the scores in section A and in section B. And these are the final exam score of students in her in the classes. So first question, what are different ways these data can be summarized? Okay, so what can you do with this data? What can you compute? What can you do? Is there a way we can describe it? I'll give you a moment. Well, one thing you could do is to calculate things like the stuff that we discussed early in chapter 2, things like average. We can compute median. We can possibly look for the mode, right? And then we can see what it is. Now, in this lesson and the next lesson, we'll be looking for tools to summarize data. And today, we're going to be looking at a particular graph, or 2 particular graphs that will help us to understand and see the data better. So Professor Johnson decided to compare the performance on the final exam by constructing something that's called a histogram. So that's the first visual tool we're going to learn here. A histogram is the most common graphical representation of data. It requires data to divide into groups or categories of equal size. So I'll highlight this as well, is that the size has to be equal. And here's what we're going to try to do now, is to do exactly that. You want to count how many final exam scores are in each of the categories for each section of Professor Johnson's quantitative reasoning course. And then we're going to count how many in each category. For instance, let me just get you started. We're looking at the category 41 to 50. So that includes all of the scores between 41 and 50, including 50 itself. So then to calculate how many we have in that category, we're going to look at section A, right? And we're going to go until it says 51, correct? So it's from 41 to 50. So in section A, we only have 1 student there. So that will be the frequency. So that will be 1. All right. Between 51 and 60, we also only have 1. Between 71 and 70, so 71 and 70, including 70, we got 3, and so on. Fill out the rest. I'm going to give you some things that I would like for you to fill out. And then you, after you answer a few of those, then you will see the entire table filled out. Go ahead. You can copy this table in your notebook, or you can print this lesson and then do it that way. Here you see all of the frequency, the number of students in each category. Notice that if you add up both of those, add up to 20. So there are 20 students in each section. Okay? Alrighty, so once again, keep in mind here that all of these categories are equal. All right, that's a defining feature of the histogram. So it's now construct a histogram for each section of the course using the template provided below. Each bar of the histogram has the height that equals to the length, in length to the frequency of each category. All right, now since we have numbers up to 8, we're going to make the y-axis, the vertical axis, to go up to 8. So 4, 5, 6, 7, 8. Let's label it. Okay, you can copy this in the notebook again, or you can write it, or you can print this if you can. All right, next is we're going to do the categories, and check this out. It doesn't start at 0, so we have a little break like this. So I'm going to use this little 2 dots to represent that there are no scores that are less than 41 for the first histogram. So that will be section A. Let's put the well, actually, let's put the title here as section A. All right, and then we're going to put categories right here. And an important feature is that once we graph it, we want to make sure that these histograms, they touch. All right, they touch each other, but they don't overlap. There's no score that will be part of any categories. So it's 51 to 60, then to 70, then to 80, then to 90. They equal width, and then to 100. All right, so it's 51 to 60. This one is 61 to 70, 71 to 80, 81 to 90, and then 91 to 100. All right, so that's each category that we got. And then we're going to create a height of this. It's going to be rectangles with the height equals to the number of frequency. And you can even write the number just so we could see, how many are there. So it will be easier to interpret this. So there are 3 in this category. There are also 3 in that category. This one I got a little bit too wide. That's okay. So again, I just don't want this to be too messy. Oops. It's not that it should be the same width, okay? The next one is 4. All right, and the last one is 8. So this one, 91 to 100, that's the last one, so it's 8. All of these have to have equal widths. All right, so that's how you create a histogram. The other one is going to be a little bit quicker because it starts off at 71. So I'm going to keep these together like that, so it's kind of on the same level. So this one right here is 71 to 80. This one is 81 to 90. And this one is 91 to 100. We also should write what those are. We're going to put the score, and here we're going to put the number of students, so we know what we're looking at. And then you can do this one is section B, and these are the grades on the final exam. All right. Okay, so also 1, 2, 3, 4, 5, 6, 7, 8. So we got 8, 8, and a 4. So we got 8 here, 8 here, and this one is going to be the 4 right there. And what you got is a histogram. That's it. That's how you create it. The bars must be touching. All right, now looking at these two, all right, compare those two histograms. What do you notice? What do you see? How do they compare? I'll give you a minute to describe them. Alrighty, so one thing that you could see is that section B is more clustered in the highest scores area, right? From 70 to 100. You see no scores lower than 70, right? So they more closer together, all right? The other thing that you might have noticed is that for the first section, you have kind of like a drop-off, like where this thing is going kind of this way, where the height happens to, the peak is happening right here, and then it's kind of falling off. So you have few scores that are, there are few students who perform really, really lower than the others. And there's a very, profound peak right there at the top. Okay, while the other one is a little bit more clustered together, and you don't have students that kind of level off to the left side. Okay, you have 4 students who perform in 90s, but then the other ones are kind of all in the same score range. All right. But the main notice that you want to see is that section B is more closer together. The scores are not as spread out. So that's what I would say, is that section B, so scores in section B are less spread out. Okay, so they're more closer together. All right, so here's another way of presenting the data. So we just learned about the histogram. The other way to do to present the data is something that's called a box plot, sometimes referred as the box and whisker plot. The essential idea here is to divide the data into 4 equal groups. We'll construct a box plot for the final exam score data of Professor Johnson's section A class. So here's I'm going to show you how do you create a box plot for the scores in section A. So here's how we're going to do this. We're going to put the values in order from increasing order from smallest to largest. So these are the scores. You can see them there. All right. The minimum value, the lowest value, and the maximum value we will underline. So you can see that. Let me highlight it for you. So this is the lowest. This is the highest. And we're also locating the median. Since there are 20 numbers in that data set, then there are 2 numbers in the middle. All right. And when we have 2 numbers in the middle, we compute the median by adding those 2 and dividing it by 2. All right. And since they're the same, the median ends up being 84. Okay. All right. So now we're going to define something new. It's called the first quartile. It's from the word quarter, a fourth. It's denoted as Q1. And then we have the third quartile, 3/4, denoted by Q3. Q1 is the median of the values to the left of the overall median. So now, since we have an even number of numbers, then we have exactly 10 on the left, and we exactly have 10 on the right. Remember, median divides the data exactly in 50-50% clusters. All right. So then we find a median of each one of those. But again, because there are 10 numbers, which is an even number, we expect to find 2 in between, 70 and 74. So we calculate Q1 as the median of those 10 numbers. You see? So that's 72. And then we do the same thing for Q3, is we are taking the 2 in between, we add them up and dividing by that. All right. Now, this difference between those 2 numbers, if you subtract them, has a term. It's called the interquartile range. Here we go, interquartile range, or IQR. And that represents the middle 50% of all the data. All right. Now, if you look closer, all right, if you think about dividing this data in pieces, when you're dividing this alongside the median, you get 50% on the right and you get 50% on the left. And I think about it, if you take each half and you divide each one in half, what does it do? It divides each half in half. So overall, it creates a 25% markers. This is the lower 25%. All right. And then here would be the higher 25%. And then this middle 25 right here, that's together equal to 50. That's your IQR. So the concept here is just simply put the numbers in order and focus not on an average, but focus on the physical center of each piece. All right. So the median is the physical center, and then Q1 is the quarter of the data, the first quarter, and then the Q3 gives us the top quarter. You understand? You might have heard about percentiles. This is very similar. Okay, these are basically the markers that divide our data in pieces, into 4 equal pieces. All right, so now, how do you create a box plot from that? So we use the 5 values that we found, the minimum, the Q1, the median, the Q3, and the maximum, to create a box plot. So look how you do this. You basically identify the largest number, 100, the lowest number, which was 40 something for the section A. All right. Then you got the median, which was equal to, what was the median? 84. All right. You have the Q1, which is right here. That's the first quarter of the data. So the Q1 was 72. And you have Q3, which is 95.5. All right. And the way you construct this, you basically do it like this, guys. You got Q1, you got Q3, and you got the median. And then what you do, you draw the 3 horizontal lines, and then you create a box, a rectangle like that. All right. And then you identify the lowest point, the minimum, the highest point, the maximum, and you draw whiskers. These little lines that go like this. All right. This is your IQR. That tells you where the middle 50% of the data is located. And then also, the median gives you the center. Half of the points on the above it, the half of the numbers to the below it. And then you can also see the minimum and the maximum there. All right. If you looking at the box plot and knowing the definition of Q1, median, and Q3, answer the following question. So the first quartile, the Q1, for the exam score the student received in section A was 72. All right. You see it right here. Interpret the meaning of the number in the context of that situation. All right, I'll give you a moment. Answer the question. All right, so the Q1 represents the lower 25% of the data. That's what that is, right? It's the first 25%. So that means that 25% of the scores are 72 or lower. You understand? So that's the cut for the lower scores. That means that the other 75% of the scores, the other side, are higher than 72. You understand? So the Q1 represents the 25%. So you got 25% of the students scored somewhere in that region. Only 25%. So even though it looks like a long whisker, it doesn't mean that there are a lot of data points there. No, it's only a quarter of the class that are in that region. All right, so the first quartile for the exam scores the students received in section 8 was 95.5. Interpret the meaning of the number in the context of that situation. I'll give you a moment. All right, so the Q3 is the top 25% of the students, or top 25% of the scores. So that means that 25% of the scores, how did you write it over here? Yeah, 25% of the scores are equal to, well, since the score can be 95.5 for most exams, so we're going to say 25 of the scores are equal to, we want to be higher or equal, so we can't use 95, so we have to round it up. So are equal to 96 or higher. All right, so about quarter of the class scored either 96 or anything higher than 96. So that tells us there's a big big group of students, all right, exactly here, that score, that tells us that there's a big bulk of students. So even though this thing is short, right, that whisker is short, it does tell it that there are a lot of data in that cluster, in that small cluster. All right, and finally, interpret the meaning of the interquartile range in the context of this problem. I'll give you a moment. Well, this is IQR that represents middle 50%. All right, so that means how would you say, middle 50% of the scores are between, and then we take those two numbers, right? So we have 72 and 95.5 between. So that means that 50% of the students score there. Another way you can say is that 25% of the students score higher than the median, but less than 95.5. And the other 25% of the students score less than the median, but more than 72. Okay? Alrighty, I'll give you a moment to create a picture of the box plot for the other section, for section B. So follow the same process. So look at the data for section B. Where is it? Oh, it's all the way at the beginning, right here. And construct a box plot similar way, okay? And just take your time and do it, okay? It's a valuable practice to identify what's the Q1, what's the Q3. Those are the type of questions I'm going to ask you right now on a poll. All right, let's review. So the median here is going to be the number in between 81 and 84. So that would be what? You add them up and you divide it by 2. So that gives you 82.5. You need a 5-number summary in order to make a box plot, okay? So then check this out. So this is exactly in the middle. Then you're gonna take these numbers right here and you identify the middle of that list. Since there are 10 numbers, the 5th and the 6th number will be right in the middle. So that means that the Q1 is going to cut this in 2 pieces. I mean, the Q1 is going to be the median, so it's 75 plus 76 divided by 2, or simply the number in between. And then the same thing here. The middle of this is going to be the 89, correct? And then you have the lowest, and you have the highest. All right, so I'm gonna make a quick sketch here, just again to remind you how this is done, and then I'll show you how they those two compare to one another. Alrighty, so those two sections. So we create a picture like this. So approximately, now you see it starts really, you know, at 70. So I mean at 73. So we basically have a big gap right here, and then you have, let's say, 70. And then you got all the way to 89. So we can do 75, we can do 80, we can do 85, we can do 90, just so that equal steps. Just, you know, quickly show you how the box plot is made. So you do the Q1, you do the median, you do the Q3, which is 89, like that. You create a box like this, and then you do the whiskers to the lowest number, like this, and the highest number, which is 95, like that. You understand? That's how you create it. You got the Q1, you get the median, and you get Q3. Sometimes you see the box plot drawn in a horizontal way, like this. That's acceptable as well. All right, it's going where you put the scores in a horizontal axis. That's acceptable. Alrighty. Okay, here they are drawn next to each other. So you have the section A and you have a section B. All right, so take a look at this, take a closer look at this. And then here's the question that's going to follow. Let's go to the lesson. Where is it? One moment. All right, here's a question. Compare the two box plots. Based on this comparison, which section of student performed better? And explain your reasoning. So I'll give you a moment. All right, so let me show you the answers right here. So answers can vary, guys. You might say that the scores were higher for what section? It appears that there are more students who score higher in which section? In section A, right? But score are more spread out. As you can see in section A, it goes all the way to 45, while the other one is more consistent, right? Section B is more consistent. So professor, for example, might value consistency more than the actual students who perform better. For instance, in my classes, I would rather see consistency in scores rather than big spread out. So consistency is always better, in my opinion. But some might value having more higher scores. I don't know, but anyway, it depends on what you're looking for. Okay, ideally you want everybody to score very high, but practically speaking, you want some consistency in your scores. You don't want to have a big gaps between the results. So section A is kind of more realistic of what you would see in a real classroom. Alrighty, so moving on. There's another thing that I would like to cover in this lesson, also from statistics, and that is, you probably heard about grading on a curve. Like, you're gonna curve the test and things like that. So curve is interesting idea, and I mean it's curving in mathematics can be as simple as just adding everybody an X amount of points to the score. That's what most of the time is done. But real mathematical curving that's done like on standardized examination is to bring everybody to the same kind of level, and that's what's done at large university, for example, and that's what's done right here. So let's read about real curving, right? Not just adding points, but real curving. Vanessa just finished a class called Fundamentals of Music, an elective course she's taking this semester. Her overall average in class is 91, which she assumes will give her an A in the course. At the school, there are only 5 grades, A, B, C, D, and F, no pluses or minuses. However, she's concerned. At the beginning of the course, her professor told the class that he would be grading on a curve, which seemed to make most of the people in the class happy. On the last class, however, Professor Jones explained what grading on a curve would actually mean. He is required by the music department to assign grades so that no more than 25% of the scores are given an A or D, and no more than 50% are grades B or C. So basically the curving is standardizing everybody so that the top 25% of the students are getting an A, the bottom 25% of the students are getting a D, and then everybody else are going to get either B or C, where, the middle 25% are basically B's and C, spread out kind of a similar way that we just talked about box plot. So here you see actually the graph of the box plot, and you also see next to it the histogram of the grades, of the points, not of the grades, but of the points that the students earn in that class. All right, it looks like we're looking only at one section. So the first question that we are asked, describe the distribution of score using the data presented on both charts. Try to be as complete as possible. Use complete sentences. So write down, what do you see? So can you describe it? Write as whatever you can, but based on the data that you see visualized here. I'll give you a moment. All right, so what you could say is that the data right here, that the scores are pretty high. You have no scores less than 70. You also see that scores, just like the other histogram, is leveling down as you go to the left. All right, so you have the bulk of scores on the right, and then you have some lower scores, they're not low scores, but they're lower to the left. Okay, so there's a bigger cluster of students that are located in the top of this. All right, so if you look at the histogram, at the box plot, which gives us even a better picture, this number right here is a median, which looks like it's about 90, maybe 91. So that means 50% of the students score higher than 91, including Vanessa, who scored 91. in terms of the row score. So that's put her in the top 50%, but not the top 25%, which is needed for an A. And that's the next question. So is she getting an A in the course? Yes or no? If you grade on a curve which says that only top 25% of the students are getting an A. Give you a moment. So is she getting an A? Well, if you look at the chart again, she's not. Because she is right here. So it looks like she is in the B range, even though she got 91. Just because she does not fall in the top 25%. So is there a question? Well, it doesn't say what score should one receive to get an A. Well, you have to be above the third quartile. All right, so if you zoom this in, it's not clear from the data, but it looks like it's a score of 97 or higher will give an A. All right, so then what's going on? We hear about curving being a good thing. So how does curve grade benefit or hurt students in this particular class? Well, if you look at this chart, I don't see people benefiting as much, because anybody who scored more than 90, all right, they're not getting an A, so it's hurting the students who earned a higher row score. It's definitely hurting that. It's hurting the students who would have gotten an A, but getting a B right here, so it's hurting those students. How about the other ones? I mean, the other ones are hurting as well, because look at this. Normally, anybody who would score between 80 and 90 will receive a B, but in this case, the students who scored higher than 85 are getting a C, and students who scored less than 85 but more than 70, that's getting a D. So this is really, really unfair for this particular class. So for this class, no one is benefiting. All right, no one is benefiting. Everybody has actually hurt with this grading. So when would the grading and a curve be beneficial? When do you think? Let me give you a moment. Well, if it was the other way around, right, and people did really, really poorly overall in a class in such a way, let's say we have a picture like this, where you have this kind of like, it looks like a syringe, right, like that. If that syringe was in the lower end, where let's say here we got the scores like, let's say the highest score in the class was like, well, let's make it high like this. Let's say somebody did get maybe 95, right? But majority of students were, let's say, score like 65, all right? So that means that everybody who scored higher than 65 will be getting an A. Then this median, let's say that was something like 50. I'm just making up the numbers. Those are going to the B's. This will be the C's. And let's say this one right here would be the D's. And anything less than 20 will get an F. So if the scores were spread out the other way, where the high scores are low, when there are more lower scores than the higher scores, then the grading on a curve would be beneficial. A lot of times at the large universities, when you take classes like biology, chemistry, calculus, something that's big, there are thousands of students taking that class, the distribution tend to look like this. And therefore, what the departments do, they do grade them on a curve. So students who are in the top 25% or whatever, they do get those A's. And the A's does not really mean that their row score is in 90s. No, their row score might be in 80s and they still earn an A. So in those type of classes, high volume classes, grading on a curve is useful and helpful to the students, while in a regular, one section classes, grading on a curve is not even implemented. You just get extra points, you might, for something to help you to boost your average, but it's not really a mathematical curve. What's described in this lesson is what the curving is all about. Alrighty, so on that, we're going to finish our lesson today.